Hi, Nikki here with Nikki Does once again. I was looking at the NTSB report that came out about the Dali, the ship that ran into the Key Bridge, and it's gotten a lot of attention lately. And when it got to the part about the wire and the ferrule that was stuck with the heat shrink tubing label that was stuck on top of the ferrule and that it wouldn't fit into the terminal block, which is like this. I'll do a spoiler and show you. I have these. I use these quite often. I thought it would be kind of interesting to do an actual live, no animation type of video and show how these actually come together and why they are so cool. They are definitely awesome, but I certainly can see the problem that happened here. And I can't say I've had that problem, but I've seen problems similar to that when wiring electrical panels. So I'm going to jump over here to a camera. Well, let's take a look here at the video on YouTube first. And bear with me a moment whilst we kind of get that video started here. So these are the actual terminal blocks in a panel, in an electrical panel. And you can see, let's get back to this. You can see here each wire goes into a hole. And if we are to look on the left and we see the wire, like wire number 373, next to wire 373 is a square hole. And that's where a screwdriver goes in to open the cage clamp terminal. I'll show that in just a minute. Then keep going to the right, you have the terminal marker 373 that presses into a very dedicated space. Then there's another much more, so I should have said square hole earlier. So then there's a much more rectangular hole to the right of that. That's where jumpers can go in to connect, say, 373 to 374 and 375 and 376. You can jumper any of those together, and that would be if you ran out of holes in this terminal and you needed more places for wires. Say ground wires or power wires, and you need lots of them to be together, the same voltage, the same, basically connected. And then you go to the right and you see another square hole. That one is for a screwdriver, which will open the clamp for the round hole to the right of it. Then another square hole, which will be for a screwdriver to open the cage clamp for yet the last round hole on the right of it. So if you look, this terminal block that's showing can take three wires, one on the left, one in the middle right, and one to the very far right. And the little blue doohickeys, the little rings that are around the wires just below the labels, those are ferrules, and we'll show those too. I don't have blue ones, but we'll show those. And this is an absolutely typical electrical panel, something you'll see in every machine, every control room, in a power plant, in a paper mill, manufacturing machinery, energy production. Solar would use these. Basically anywhere where you can't use a wire harness, meaning the wires are already put into a special plug. Like your HDMI cable on a computer or TV would be a pre-made wire system with a connector already built onto the end. This is made for what's called discrete wiring, as in individually wiring each terminal. So the technician, the person who builds this, would have a wiring diagram, and that wiring diagram would say wire number 376 has to go over to the overload relay terminal number 5. So the technician cuts off a piece of wire of the appropriate length, strips the ends, puts the ferrules on each end, puts the heat shrink label on, puts the ferrules on each end, and then installs the wire by pressing the little screwdriver into the square hole, putting the wire in there, removing the screwdriver. So that's a lot of talk. Let's actually show that in process here. All right, so here we go with this is kind of everything that the Dali used. Now, I have other Wago terminals. These are almost certain, just from looking at the video. Let's go back to the video here for a second. If we look at the video, and we go forward just a bit. There we go. That's going to be the ferrule. and they show a side view of the cage clamp system. So that looks quite identical to this. So here is the cage clamp, and here it is on YouTube. So I'm quite sure that that was a Wago terminal. I mean, everything is quite identical. Now, the thing you see on the NTSB video is certainly a model of this, but the model, and so the model isn't absolutely 100% perfect, but this is a cage clamp design. I'm going to show that one more time just because I think, and this is a German manufacturer, Wago, Wago, I don't know how you pronounce it, but just a phenomenally high quality and beautiful system. This is in no way, in my mind, is no way implicated in the problem here with the Dali. This was, in fact, a rather easy to make wiring mistake that I wouldn't blame really anybody for. I think it just happens. So let's take a look. And this is really an amazing terminal block system compared to some others, which I've got, but I didn't bring over here. So let's just start at the basics. It starts with a DIN rail. DIN is a standard. This is just called a piece of DIN rail, and this would be mounted usually vertically on the wall of the cabinet, so you can look straight into this just as you are now. And then these are Wago terminal blocks, and they nest together quite nicely when they're a bitty clip here in the end, and when you push it together like this, they snap into place, and you get a fairly, they stick together like this. So now if you're putting this together, you would count out the number you need on the terminal for your wiring, and you would set in the one side, so this would clip onto the DIN rail like this, and then you snap them on. Super easy to do, fast, and really secure. So now they're snapped onto this DIN rail, and they're essentially permanently in place. If you need to remove them, you can take your screwdriver, which this is like the only tool you need to do all the wiring. You take your screwdriver, put it in here, and you just pry this one up. So you pry this out, it unlatches from one side of the DIN rail, and it comes up, and you can easily snap this right out. If you needed to replace the terminal for some reason, you could snap a new one in. Now, I mentioned these slots on the top. You can press in a jumper. That's not relevant for here, but that's how you jumper together multiples of these. So in this case, this wire will connect across to this wire. Okay, so that's how they sit on the DIN rail, and this is the side of one. And I thought this would be kind of interesting to see how they work. So let's get a little zoomed in here. So here's the round hole that I mentioned, and there's the square hole. And the square hole is for a screwdriver. And the screwdriver comes in here like this, and when you bend the screwdriver to the side, that opens up the cage clamp. So the cage clamp, let's take this one out of here. They're not supposed to come out. This is not something you'd normally do. But this is for illustration. So let's take out this one cage clamp right here. And the way the cage clamp works, let's wait for it to focus. When you push this forward, you'll see that cage clamp opens up, a hole opens up. Probably be easier to use something like this. Let's get it in frame here. Now this space here is where the wire goes. So now that wire, and it's just a ferrule, but if that wire would be, it's quite springy, and it's that way on purpose. So this is harder than it looks. Let's actually put a piece of wire in there. So here's a wire that I stripped beforehand, and you can put this wire in there, and when you let go, it will pinch the wire in that space. So now that wire is, you can see it's ever so slightly into the cage clamp, and it's right there is the end of the wire. So in this case, the wire is barely in there, and it's still quite well held in, but I could pull it out. So if you were to put the wire in properly, let's see if we can figure a way to do that. It'll take a bit of physical gyration. to get this to work because it's all spring-loaded. Okay, so now you can put the wire in this way. So this is just a bare wire. There's no ferrule on here, and you can see the wire is nicely pinched in that cage clamp. And furthermore, it flattens out the wires in this case, so you get quite a bit of contact between the cage clamp and the wire. It does a great job of communicating the current through here. But a lot of times you're a bit concerned. So this wire can have a number of problems if you just put the wire in without the ferrule on the end. I'm going to show you the ferrule in a minute. These are ferrules. But this is a weak point here. Like if this vibrates quite a bit, that wire is bending right at that sharp edge where it's meeting, and you can see one of those is already broken right there. So if this were in service for quite some time, especially in a high vibration environment, like say a ship, it doesn't take many times before the wire could just end up breaking right off. And as more and more wires are breaking here, I'm feeling it getting easier and easier to bend this back and forth. You can already see quite a few wires have come free. And this is where the ferrules come in. So I'm going to just break this off to show that does happen, right? So this is where the ferrules come in, and I think they're quite a great thing to add, and many of the wiring systems require them. So a ferrule, you would take the wire, just like we had before, and strip off an appropriate amount of the wire, and now you set the wire into a ferrule, which is this reinforcing ring. And it does a number of things. First, it makes sure that no stray wires that are over here, like that pop out of this, when you shove them into the terminal, no stray wires can be sitting out to the side and thus connect with the wire next to it. And that's really important because that's a common wiring error. You could see here if I push this one in like this, and the wire stuck out to the left here, whatever wires to the right that may contact it, and this would be a short, it would crosstalk between these two channels. So that's one of the main things it does. And the other one it does is it keeps the strain on the wire to the wire that's enclosed in insulation. So now that wire can't bend back and forth but just a tiny bit here because the rest of the wire is enclosed by this sheath, by this plastic sheath. So I think they're really great, and I really do like to use them. I think they save way more than they hurt. Now in this case they hurt. This is the problem. The crimper for this looks like this. It's rather a clever tool. And you put the ferrule and wire into the crimper, and you give it a squeeze, and it crimps the ferrule onto the wire in 6 places. And now that ferrule is essentially one with the wire. Electrically, it's very much one with the wire. And now when you go to put this into the terminal block, let's do it in the real terminal block. So I'm going to release this terminal block. And I'm going to, this will be a lot easier for me certainly, I'm going to press this in. And now I'm going to take the wire and drop it in here right into the hole. And now you're not going to see it go in because that flag piece of metal is in the way, but it's going to go right into the hole and it'll drop right down into the cage clamp. Right there. It's a little harder to do if you're holding the terminal block. They're normally on the DIN rail, and I'll show you that in just a minute. Now that wire is beautifully tied into there. It's clean. There's no tails of wire hanging out here to short out next to it. It's vibration resistant, and normally it would have a wire marker on it. And I've simulated that here too. So here is a piece of, this just happens to be heat shrink tubing, and that can go over the ferrule right here. Now you'll see the ferrule largely goes into the hole of the terminal block. So again, there's the terminal block hole, and there's the collar of the ferrule. You have the wire part of the ferrule, and then you have the collar, and you see the collar actually goes into the terminal block hole. And that would be fine if there's plenty of clearance. So here's a larger ferrule, and notice that doesn't go in there. The wire ferrule will not fit into the hole, so that one wouldn't work. So if we tried to do the same thing, and let's do that here, With a wire with a larger ferrule on it, the ferrule won't sit properly into the cage clamp, and that's not enough engagement right there. So if you made a mistake with the ferrule diameter, and you were using too large of wire, or you chose the wrong ferrule, you're going to have this problem where the ferrule doesn't actually fit into the hole, and therefore it doesn't make appropriate connection with the cage clamp down below. Now that's not exactly what happened. What happened with the Dali is that there was a heat shrink label on there, and we can go back and take a quick peek at the YouTube video. And that was about here. So there's the ferrule, and you'll see here that the heat shrink should be above the ferrule like they show in this video. But in the Dali, in this one exact wire, the heat shrink was placed over the ferrule, increasing the diameter of this, in this video, blue ferrule. And let's pause this and we'll go back and look at the overhead view. And now this ferrule is too large, just like I've simulated with this one. Now let's go ahead and do another one. It's really obvious if you have a wire that's poking out and you try to push it in. It's really obvious because the ferrule gets stuck. So it's really quite a good tool. Certainly early in my career, we didn't use these often. You just put the wire in, but there were enough failures to justify the added effort to put on the ferrules. So now with this larger ferrule, here I have the smaller one, the red one, and that one will go all the way into the cage clamp. And you can see here, if I press this in, it drops all the way down to the bottom, but this black one only goes in a little bit. See how far the metal part goes in there? It only goes in to the very top of the cage clamp. Now, the cage clamp starts right at the tip of my fingernail right there. So this would only just barely hold in. Now, if you put this in and you started pulling on it, it might feel like it's connected, but it's not connected very well, and it probably isn't going to survive a lot of vibration. Whereas if you put this one in, it goes all the way down to the bottom like that. Again, the cage clamp is at that line right there. It's going to hold very, very well. So in the Dali, when they put the heat shrinkable label on and heat shrunk it, it turned this diameter ferrule into something more akin to this diameter ferrule and didn't fit in there. That would have been fine if the heat shrink label was kept up on the wire, but somebody either didn't know, wasn't trained, whoever inspected didn't catch it. They put the heat shrink label down here and it didn't fit properly into the cage clamp. So one little thing like that, this is a case where when we talk about accident chains, where there's almost always, in most all accidents, there's some kind of warning followed by another warning, followed by another problem, followed by another problem, until finally a catastrophic accident occurs. This accident was nothing like that. This accident had essentially no warning whatsoever because there was one mistake made. One mistake putting the heat shrink over here resulted in a death of 7 people and cost and inconvenience in the millions and billions of dollars. It's absolutely amazing, the society we depend on every day. Well, I hope this was informative, and I hope it adds to the Dali explanation, and thank you for watching, and leave your comments down below.